Welcome to Module 5, Data Visualization. We can see from this pipeline, data visualization's position in the business analytics pipeline is the final stage before the data reaches the end user. After the data has been analyzed, it moves into the visualization stage. This is the part highlighted in the red box. Here, the insights derived from the analysis are transformed into an easily understandable and consumable format for the business user. This includes creating dashboard, which is interactive displays that provide a quick overview of key performance indicators. Also, we call them KPIs. And scorecard, which is a tools that track progress towards specific goals, often using color-coded indicators. And reporting, which is detailed documents or presentations that summarize the findings. Decades of the research in psychology show that our brains process pictures and visuals much faster than raw numbers in tables. That is why data visualization is so important in business analytics. By turning complex dataset into charts and graphs, we can quickly spot errors, highlight relationships, and detect trends, all while reducing the amount of the data we need to sift through. For example, a box plot makes it easy to detect outliers, while a scatter plot helps us see whether two variables move together or in opposite directions. And beyond simple analysis, visualization also powers advanced tools like recommendation engines, which analyze user pattern to suggest products or content. So whether it's for detecting outliers, finding relationships, or building AI systems, data visualization delivers faster, clearer, and more actionable insights. If you want to learn more about data visualization, here is a book recommended. This is where I learned data visualization the most. When we design data visualizations, one important concept is cognitive load, which is the amount of mental effort required for someone to process and understand the information. To reduce cognitive load, we use pre-attentive attributes, visual features that people noticed instantly, like color, size, shape, and length. The color is powerful for highlighting difference, but it should be used carefully. Overuse can be distracting, and we must also remember that color blindness makes some color combinations ineffective. Size can also be used, but people are not very good at judging difference in two-dimensional area. This is why it must be applied consciously. Length, on the other hand, is one of the most effective tools. It's easy for us to compare line length or bar heights, which is why bar and column charts are often better than pie charts. So in short, by using pre-attentive attributes wisely, we can make our visualizations easier, faster, and clearer to understand. The data ink ratio is the ratio of the amount of the ink used in table or chart that is necessary to convey information to the total amount of the ink used in a table and chart. Ink used that is not necessary to convey information reduced the data ink ratio. So the data ink is the ink used in a table or chart that is necessary to convey the meaning of the data to the audience. And on the other side, non-data ink is the ink used in a table or chart that serves no useful purpose in conveying the data to the audience. So removing the unnecessary lines has increased the white space, making it easier to read both the table and the chart. The process of increasing the data ink ratio by adding a white space is also known as decluttering. The fundamental idea in creating effective tables and charts is to make them as simple as possible to convey information to the reader. For example, let's look at these two tables. On the left, we see a low data-ink ratio. There are grid lines and repeated labels that don't add meanings. These extras force the reader to spend more effort filtering out what really matters. On the right, we see a high data-ink ratio. The same information is presented more clearly. No grid lines, headers showing only once, and a compact two-column layout. These choices emphasize the actual data and make the table easier to read. This process of removing unnecessary elements is called delectering. The key idea is to design charts and tables so they are as simple as possible while still communicating all the essential information. Less clutter means clear insights. The table. A table is considered as a form of visualization because it organizes and presents data in a structured visual format that facilitates interpretation and analysis. Tables are most effective where readers need exact numbers rather than just spotting general patterns or trends. They are especially useful when precise comparisons are required, or when the data contains different units of measurement or values that vary widely in score. But a table is only good as its design. A well-designed table allows readers to interpret information quickly and accurately. To achieve this, we should avoid vertical lines unless they truly improve clarity, and use horizontal lines sparingly, mainly to separate readings from data values or to highlight totals. By removing unnecessary lines and clutter, we can keep the focus on data itself, making tables clear, efficient, and easy to read. Let's see this example. On top left, bold and double borders frame the table. Horizontal and vertical grip lines are prominent. The design uses a substantial amount of the ink for the grid and framing elements. So the data ink ratio is very low because the thick lines and heavy framing add unnecessary visual weight that doesn't enhance the understanding of the data. On bottom left table, the borders are thinner and less prominent. The grid lines are still present, but they are less obtrusive than in the design A. The data ink ratio is moderate. While there is less ink used in non-data element compared to design A, the grid lines could still be minimized for further improvement. On top right table, only necessary grid lines remain. No vertical grid lines are present. The design uses white space effectively to differentiate columns. The data ink ratio is high. The removal of the vertical grid lines and reliance on white space makes this design more efficient at presenting data without excess ink. On bottom right table, minimum borders and no grid lines. White space is used entirely for alignment and separated of rows and columns. So the data ink ratio is very high. This design elements all non-essential ink, focusing entirely on the data itself. And in visualization, we always use a term called cross-tabulation, often called a crosstab, as the statistic tools used to examine the relationship between two or more categorical variables. It involves creating a table that shows the frequency distribution of the variables and provided a visual way to observe how they interact or correlate. Let's see this example. We start with the raw dataset showing 10 restaurants with details on quality rating, meal price, and wait time. On its own, the data is useful, but it can be hard to see relationships at a glance. That's where a cross-tabulation comes in. In a crosstab, we'll place one variable on the rows and another one on the columns to form a grade. In this example, the row represents quality rating, including good, very good, and excellent. The column represents meal price range from 10 to 19, 20 to 29, 30 to 39, and 40 to 49. And each cell shows a frequency count, which is the number of the restaurant that match both conditions. For instance, the restaurants rated very good with meal price of 20 to 29. The amount of this kind of restaurant is 64. By arranging the data this way, the table makes it much easier to spot patterns and relationships. So whether high-rated restaurants also tend to charge higher price. And in Microsoft Excel, this type of cross tabulation is created using pivot table. There's multiple software can do cross tabulation. We can do it in Excel and Tableau. So let's check about it one by one. As same as before, we need to collect the data from SQL. Thus, before we start, please insert the example data into MySQL. You need to download the files w3school.sql and model5datasource.sql, then run it in your MySQL. You need this data for both your practice and assignment.
Now let's see how to do this in the Excel. We can, in the MySQL, we can select all from the restaurant data and then copy paste all the data into a new Excel file. And don't forget about the column names. And then after we copy paste the data into the Excel, we can click the insert on the ribbon and then click pivot table button in the tables group. And when the create pivot table dialog box appears, we're gonna choose a select a table or range and enter A1 to D301 in the table range. And then select new worksheet as the location for the pivot table report, and then click OK. And then in the pivot table field task pane, go to drag fields between area. We're going to drag the quality rating into the rows, and then drag the meal price into the columns. And then we're going to drag the restaurant field to the values area. And then we click on the sum of the restaurant in the value area. And instead of summary, we select count because we don't want the number of the restaurant or just the IDs. We want we want to know amount of them instead of the summary of all the IDs. And then we have to create the bins, right? So we right click the any cells containing a meal price column and select group. And we enter 10 at start at, and we enter 49 in the end at box, and enter 10 in the buy. And then we right click, we click OK. And then last, we can right click on excellent and move it to the end so that we have the good, very good, and excellent ranking.
Now let's see how to do it in Tableau. So when you open a Tableau, you will see a panel on the left. So we will using the Excel we just created to work it in the Tableau. So we go here on the panel, click the Microsoft Excel. And then we will choose the Excel you just created, and it's right here. I called it the restaurant, and then so I open it. And after I open it, you will see this is the source. So I have the different column names, the file names here, and then I can see the original data right here. And now to walk into the Tableau to create the tables or graphs, we will choose the sheet, so worksheet right here. And we go to the sheet 1, and then here we can work on it. If you want to create a new one, you can click here on a new worksheet, and then we can do another one. Okay, so let's go to the sheet 1, and then you have to watch out right here. We have the data source. This is the data restaurant we just created. This is from the data source. And then later, if you want to do some other Tableau job, then you will have a new data source. And then so you need to check about right here to make sure that you have the correct data source.
Now we can see that the restaurant data has been, the columns are all here. So if we want to create a cross tabulation like this, what we need to do is we should put the meal price and the quantity rating into the row and column. So we know that the quantity rating is the rows. So I put it here. So we can see that the quantity rating is rows here. And the meal price, since we want to create the bins, right? So we need right-click the meal price, and you can tell that here the meal price are a number. So we need to change this. So we right-click the meal price and then click create, and then create bins. So far we can see that this is the size of the bin generated by itself. Based on the minimum and maximum and the range. So what we can do is we can set the bins by ourselves, which is we can change it to 10. And click OK. So now we can see that here we have a new column called a feature called the meal price bin. And then we put this into the column. And now we see that here are like 4 groups, like 4 bins of the meal price. However, these are all empty yet, right? So we still has to put the meal price, the original data, into this ones. So we drag the meal price to the marks on the marks here and change this, the detail, to the text. So it's showing the value of the meal price. However, so far it's still not done yet. So far, the meal price are shown as the summary value. So we have to change the mirrors instead of the summary. We're going to change it to the count. And now you can see that this is the count of the meal price that with the count of the restaurants in the different groups of the meal price with the quantity rating, right? So then we can click the excellent and drag it down to the bottom. And so we can see that they are good, very good, and excellent. All right, so, and you can do something else. For example, we can edit alias to from 10 to 19, and we can change this to 20 to 29. Same thing here, 30 to 39. And the last one is 40 to 49. Okay, so far this is the cross tabulation we just created. Furthermore, we can add the total value of the columns and rows. So by doing so, we can click the analytics and then find the totals and then drag the totals into the cross tabulation. And we can put in the row and we can put in the columns grand total.
Charts or graphs are visual methods for displaying data. There are 2 common types of chart called scatter or line chart. Scatter chart is a graphic presentation of the relationship between 2 quantitative variables. Line charts are similar to scatter chart, but a line connects the points in the chart. Line charts are very useful for time series data collected over a period of time, like minutes, hours, days, or years. Trend line is a line that provides an approximation of the relationship between variables in both charts. The scatter chart or scatter plot is a visualization that uses point on a 2-dimensional graph to show the relationship between 2 variables. On the x-axis, we place the independent or explanatory variable. On the y-axis, we place the dependent or response variable. Each point on the chart represents one observation, showing a pair of values. Scatter plots are especially powerful for spotting patterns or correlations. To make interpretation easier, we can add a trend line, and the trend line summarizes the overall direction of the data, often use linear regression. This not only highlights whether a trend exists, but also provides a basic for making predictions or estimating the strength of the relationship. If points cluster along an upward slope, this suggests a positive relationship. If they cluster along a downward slope, it suggests a negative relationship. And if the points are scattered randomly, it may indicate no clear correlation. For example, when we have a simple table listing the sales of the cars for a northern region from January to December, we can present this table in a way of scatter chart. This chart plots each month's sales as a single point. The points are scattered, but a blue trend line is added to show the general direction of the sales over the year. In this case, the trend line is nearly flat or slightly downward, suggesting that there is no strong upward or downward trend in sales over the year. A line chart is used to visualize trends or changes in data over time or another continuous variable. It connects individual data points with a straight line. It is one of the most widely used tools for tracking changes over time, such as across months, days, or years. They clearly illustrate upward or downward trends, stability, and fluctuations in data. Because the points in a line chart are logically connected, this type of visualization is especially effective for continuous data. In addition, multiple lines can be plotted on the same chart, allowing comparison between different datasets. In the example shown, the North region exhibits a clearly upward trend from January to March, peaking at around $140. After March, sales steadily decline, reaching about $85 in June. Then a sharp increase occurs in July, followed by a consistent decline through December, where sales fall to their lowest point of $40. The South region, by contrast, starts with relatively low sales but shows gradual growth from January to July, peaking at around $75. Sales then stabilize around $65 from August to October, before increasing further in November and December to reach $80. Overall, the North maintains higher sales for most of the year, but experiences more dramatic fluctuations, with sharp rises and falls. The South displays steadier and more gradual growth, eventually surpassing the North by October and sustain higher sales through the end of the year. This contrast highlights how line charts can reveal not only individual trends, but also meaningful differences between datasets.
Okay, now let's see how to do it in Excel. So the same thing, we're using the stack all from the sales data to get all the information, the data of this table. And we select all, which is Control A, okay? And right click the copy rows with name tab separated. And then we open new blank cell and then Control V to copy everything. And now we highlight the Northern and then North, Northern and North, and then go Insert and click Scatter, and then click Scatter right here. And now we can add the trend line, which is in Chart Design, add Chart Elements, and click the trend line, and we select the linear. And now we have the trend line here. And to remove the grids, we can also click Add Trend Line, add Chart Elements, and we can see the gray line here. And this so far is select primary major horizontal and primary major vertical. So we're gonna click both of them to remove them. And now you have seen this one. And we can also change the line, format of this line by right click and format trend lines. And then if we want to change it to solid line, we can click right here, fill and lines. And then if we don't like this dash type, we can change it to solid, and we can make it a bit wide, make it a little bit more fat or thinner. Okay, so you can do anything you want. And we can also change the color to the red or to the yellow as you want. Okay, so we're just gonna make it back.
Same thing in a Tableau. We create a new Microsoft Excel using the Excel we just created, which is the sales data right now. Sales data here, and click open. And we'll see a new data source, which is called sales data. And then we go to a new worksheet. And now we're gonna keep working on this.
We can drag the month to the columns and then drag the north to the rows. And instead of the sum, we will change it to the attribute. And so far it is not a scatter plot. So we can change right here, click the marks, click here, change the automatic to the circle. Okay, so now you can see these are the circles. So this is at a scatter plot. However, if we want to add a trend line here, we can click the add next, and then but there's no trend line. So the reason there's no trend line is because the x-axis are all text values like Jan, February, March. So the tablet itself cannot calculate this using the text value to calculate the trend line. So that's why we have another one called month number. So we will just using the month number and then change it to dimension and then remove the month. So now we have the scatter plot like this. And then we can go to the analytics to add the trend line. Drag here and then put it on a linear. So now we have a linear trend line right here. So this is how we created a scatter plot in Tableau using a trend line. And then what we can do is we can actually format. All right, we can actually format this to remove the gray lines, to improve the data ink ratio, right? So we can click the lines right here. And then, so if we go to, we can make this as a none, and then for the, and then it's all gone. So we don't have the gray line anymore. And if you want, you can change the x-axis name or y-axis name. Okay, so you can change that. So this is how we do the scatter plot in Tableau. Okay, to do the line charts, it's similar to the scatter plot. So what we can do is we can create this one, and then we can go to the insert, and then we can click scatter with straight lines and markers. So this is one way we can do. And another way is we click insert, and here there is a insert lines. Okay, let's see how this works. If we click insert line with the markers, they can tell that the month number are viewed as another numeric data, right? Well, it's create another line because it is a numeric data, so Excel that is another line. So it build up the three lines. Excel cannot recognize it as the x-axis. But if we hide this one, okay, so if we hide this one and using this, the text of the month, the string value of the month or text value of the month, then we click line and then we click this one, then it is automatically built up as this. So you can tell these two are similar, right? But this one, since the month is a kind of category, so it viewed this month as the x-asset. So there's a little bit difference. You can do the both way, or you can do the either way you prefer. But I'm just teaching you what are the two ways to do so. Okay.
Now let's see how to do it in Tableau.
So we have a new sheet in Tableau, and then we're gonna drag the month num in the column, and then change this to dimension, and then we're gonna bring both north and south to the rows, and we're gonna change them to attribute. Okay, and now we have to combine these two graphs together, right? So there are two ways to do so. One is we can actually click this triangle and then drag them to the top. You can see that north and south. You can see the two rectangle, the green rectangle. So, and then I just like lose my mouse, and then so they combine together. Okay, this is one way. And to do this, we can just and then you can change the color so that you can see like the color is different. All right. And another way is we can right click, okay, on this rows, and then we'll click dual axis, so they combine together automatically, and then with the colors. And to add the dot on these data points, we can click this little icon, the color icon. So we can click this color icon, and then now we go all. Okay, so we go all, and then click color, and we click the markers. And now you see that the markers is right there. All right. So this is how we do the line chart with multiple line.
Bar charts and columns charts are both widely used to comparing data across categories. The distinction lies in their orientations. Bar charts use horizontal bars to represent the magnitude of a quantitative variable. Clamp charts use vertical bars for the same purpose. Let's consider the bar chart titled Bar Chart of the Accounts Managed. In this chart, the x-asset represents the number of accounts managed, and the y-asset lists the name of the individual managers. Each horizontal bar corresponds to a manager, with its length indicating the number of accounts for which the manager is responsible. This simple structure provided a quick and intuitive comparison of workloads across managers. From the visualization, we can observe that the Gentry carries the highest workload, managing 37 accounts, while Williams has the lowest workload with only 6 accounts. Such insight highlight how bar chart can effectively review disparities across categories, making them an essential tool for resource management and performance evaluation.
To create a bar chart in Excel, we can use account managed table from the MySQL. So we execute this query to get the data, and we select all, and then copy the data into a new Excel file. And then when we have this data, we can highlight the column names and the data, and then click insert with the column input. And then we can click the 2D column to have the account management with the column bar chart. And then if you want to do a bar chart, we can change from 2D column to 2D bar. then you see it is bar charts. And then you can click the chart design, and then we can disable the gray lines. And then we can also add labels here if we want to click the label at the outside end. So you will see there's a number right there. So this is how we created a bar chart in the Excel. And in Tableau, the same thing, we opened the Microsoft Excel we just created, which is the account managed. We open this file and then go to the new worksheet, and we can drag the manager's name into the column and then account manager into the rows. So we will have a column chart. And if you want to have the bar chart, then we just change these numbers, change the location of the columns and rows, and then we will have a bar chart. So I personally like the column chart, so I will put it back. And if you want to have a label right here, we can move the account managed into these marks and then change it to the labels. Then you will have number on top.
Now let's look at a histogram. A histogram shows how data values are distributed across intervals, also called classes. On the horizontal axis, we place the variable of interest. On the vertical axis, we plot a frequency measure. This could be frequency, relative frequency, or percent frequency. For each interval, we draw a rectangle. The width of the rectangle covers the class limits, and the height represents the frequency measure. When we put all the rectangles together, the histogram gives us a clear picture of the data's distribution. This makes it easy to spot important features like symmetry, skewness, or even outliers. Here's an example of histogram. On the x-axis, we see audit times in days, divided into intervals like 10 to 14, 15 to 19, and so on. On the y-axis, we have frequency, which shows how many audits fall into each interval. Each bar represents the number of the audits in the time range. Notice that the tallest bar is for 15 to 19 days, meaning most audits took about this long. Also, the distribution is skewed to the right, or positively skewed. This tells us more audits were complete in a shorter times, while fewer stretched into longer durations. One of the most important uses of histogram is to provide information about the shape or form of a distribution. Skewness, or the lack of symmetry, is an important characteristic of the shape of a distribution. This page contains 4 histograms constructed from relative frequency distribution that exhibit different patterns of skewness. Panel A shows the histogram for a set of data moderated skewed to the left. A histogram is said to be skewed to the left if its tail extended further to the left than to the right. This histogram is typical for exam scores, with no scores above 100%, most scores above 70%, and only a few really low scores. Panel B shows a histogram for a set of data moderated skewed to the right. A histogram is said to be skewed to the right if its tails extended further to the right than to the left. An example of this type of histogram would be for data such as housing price. A few expensive houses created skewness in the right tail. Panel C shows a symmetric histogram in which the left tail mirrors the shape of the right tail. Histograms for data funded in applications are never perfectly symmetric, but the histogram for many applications may be roughly symmetric. Data for SAT scores
the height and weights of the people, and so on leads to histograms that are roughly symmetric. Panel D shows a histogram highly skewed to the right. This histogram was constructed from data on the amount of customer purchases in one day at a woman's apparel store. Data from applications in business and economic often lead to histograms that are skewed to the right. For instance, data on housing price, salaries, purchase amount, and so on often result in a histogram skewed to the right.
Now we copy paste all the time data, like all, and click this into the Excel. So we're gonna create the bins, and which is from 14, 10 to 14, 15 to 19, and 24, 29, and then 34. And now we can actually click data and then click data analysis, click histogram right here, click OK. And we will add the input range and bin range, which is here. And we will, under the output range, we're gonna click the new datasheet, and then we're gonna say chart output, and we click OK. So now we can have a new histogram in the Excel.
There are some other charts or tools that can be used to improve data visualization techniques, including heat map, tree map, waterfall, and GIS. A heat map is a visualization that uses color intensity to show the magnitude of the values across the two-dimensional layout. It's a powerful tool for spotting patterns, trends, and anomalies quickly. Here, each row represented a city, and each column represented a month. The color indicated performance: darker red for negative, blue and green for positive, with intensity showing how strong the variation is. For example, Pittsburgh shows mostly red across the month, meaning consistently negative performance. In contrast, Austin displays more blue and green, signaling stronger performance with some fluctuation. This kind of visualization makes it easy to compare both across time and across cities in just a glance. A tree map is a visualization that uses rectangles of different sizes and colors to represent quantitative data across categories and subcategories. Each big rectangle shows a major category, like technology, healthcare, or financials. Inside, small rectangles represent subcategories or individual companies. The size of each block shows its weight, such as market capitalization, and the color shows performance. Red means a decrease, green means an increase, and the intensity reflects how strong the change is. In this example, technology takes up a large portion of the chart. We see a mix of red and green showing gains and losses across companies. Apple, highlighted in a large green block, stand out with both strong growth and a large market share. Tree maps are powerful when you want to see the big picture and the details at the same time. They are widely used in finance, portfolio analysis, and anywhere hierarchical comparisons matter. A waterfall chart is a visualization that demonstrates the cumulative effect of sequential positive and negative changes on the variable of interest. It is particularly effective for illustrating how an initial value is incrementally influenced by a series of additions and subtractions, ultimately arriving at a final outcome. In a waterfall chart, the variable of interest is divided into categories, such as time periods or business components, and each change is represented by a column. These columns are anchored to the cumulative height of the preceding changes. making it clear how each step contributes to the overall results. The positive changes extend upward, while negative changes extend downward. In the example provided, the chart shows the gross profit declined over the first 5 months, followed by a significant increase in the 6th month. Despite the early stepbacks, the cumulative effects yields a positive total gross profit for the period. This type of the chart allows managers and analysts to quickly identify how not only the overall outcome, but also the individual contributions that shaped it. When we bring together geospatial data with geographic visualizations, we often use what's called a Geographic Information System, or GIS. Geospatial data simply means information tied to location, things like cities, regions, or even latitude and longitude. When we put that information on the map, it becomes much easier to see patterns and relationships that might be hidden if we were only looking at tables or charts. One of the most common ways to do this is through a choropleth map, which uses shades of the color to show differences across regions. Darker shades usually mean higher values, while lighter shades means lower ones. Here we're looking at a choropleth map of Cincinnati Zoo's customer base. The darker area represents higher concentrations of visitors. As you'd expect, the greater Cincinnati area itself shows the highest density. Most of the zoo's customers live right around the city. But what's interesting is that we also see two clear clusters beyond the city center. To the north in Ohio, areas like Manson, Middletown, and Monroe stands out as a strong source of the visitors. To the south in Kentucky, places like Independence and Florence also appears as dense cluster, showing that the zoo draws a significant audience across the river as well. So in short, this map shows us that while Cincinnati Zoo is primarily supported by local residents, its customer reach extends strongly northward into Ohio and southward into Kentucky. And now that we've identified these patterns, the next question is, why do they exist? And what can they tell us about the zoo's audience? A data dashboard is essentially a visualization tool that brings together multiple metrics in one place and updates them automatically as new information comes in. At the heart of most dashboards are KPIs, or key performance indicators, which are the critical measures that help us understand how an organization is performing at any given time. Now, what makes a data dashboard effective? First, it should provide a timely summary of KPIs that matter most to the user. The goal is to inform, not overwhelm. Ideally, everything important should fit on a single screen, so the user can quickly scan and grasp the current status of operations. The KPI chosen for the dashboard also need to be meaningful. They should connect directly to the decisions the user makes. So the dashboard isn't just a report, it's a decision-making tool. And finally, a good dashboard calls attention to unusual values or outliers, the thing that might require action. But it does so in a way that draws focus without creating noise. In short, a well-designed dashboard doesn't just display data. It guides the user towards insight and action. The Balanced Scorecard, or BSC, is a powerful tool that helps organizations mirror their overall performance and ensures that all activities are aligned with the company's strategy. It is widely recognized as the most popular approach for business performance management. In this example of a coffee shop, the BSC provides a quick snapshot of performance from customer perspective. We can see a strong result in terms of customer volume, which is encouraging. However, it also highlights an area of improvement, customer satisfaction, showing us where we need to focus our efforts next. Here are the core distinctions between a dashboard and a scorecard. A dashboard is a tactical and focused on short-term decision making. It gives you a real-time, instantaneous snapshot of current business performance. Think of it as a car's dashboard. It tells you your current speed and the fuel level right now. A scorecard is a strategic and focused on long-term decision making. Its purpose is to show trends and changes over time, helping you understand your progress towards major business goals. And in terms of the usage and evaluation, a dashboard is typically used by individual managers to monitor operational performance. The performance changes are evaluated by primary decision makers or stakeholders as they happen. A scorecard is supported by a defined management strategy. Performance is measured specifically against business goals, which helps to align different departments or initiatives. Related to data and visualization, a dashboard displays live performance metrics. The goal is to visualize the data to understand the current state of the business. A scorecard displays progress by showing both metrics and targets. It often uses monthly snapshots and aligns key performance indicators, which is KPI, objectives, and actions to show how everything is interconnected. In short, a dashboard tells you what's happening right now, while a scorecard shows you how far you've come on your long-term journey and how you're progressing towards your ultimate destination.